It. Okay. Okay. I'm doing a lot of thinking. Let me see what you think. What I've been thinking. Okay. It's all in this diagram. Okay. Okay. Firstly, now if it's not clear, I'm going to go through it carefully, but I'm kind of just stumbling my way through, so I apologize for that. Okay. So this is my suggestion for the class structure. Okay, let me just see if I'm just gonna wing it. Okay, so we start out with a path, right? Now this path variable is just it's an interface, right? Let me just write this bad boy out. Okay, so we got a interface path, right? What does it define? Well, it has like vector3 get position from arc length, right? Arc length, whatever, float arc length, right? And then it also has vector3 get rotation vector. Actually, it's a quaternion, right? Quaternion get rotation blah blah blah. Okay, you get it. And then the other thing it's also got is float get total arc length, right? But that's it, right? I mean, that's all a path really is, and that's all we really need in order to do what we're doing. Okay, so what's next? That's pretty straightforward, right? Okay, next is interpolator. Okay, so here's the legend for this diagram, right? There's only two symbols that you need to understand. The first is the down arrow, and that means is a. So interpolator is a path, right? It goes up, right? So maybe I should have drawn it the other way. But okay, so interpolator is a path. What does that mean? Okay, well that means this, right? It means an interpolator is an abstract class. So abstract class interpolator is a path, right? Okay. What does interpolator do? Well, interpolator takes 2 points, a point A and then a point B, right? And that's it. That's all interpolator, how interpolator is defined. It's just that it has like a protected point A and B. And this is not an abstract class. Look, this is actually it says this dot A equals A, and then this dot B equals B. That's right. I'm not sure if my use of this is correct. Let me save this for shits and giggles. Okay, so the point of an interpolator, all interpolator is saying is that, well, look, it's one way of getting a path. One way that we can get a path is by having 2 points, and then having, and then using those 2 points, we can calculate all this stuff in the path, right? Get position from arc length, get rotation, get total arc length, blah blah blah, right? Of course, this is an abstract class path, and it's an interface, so this probably needs to. This doesn't actually work, does it? Because then this actually has to implement those things. But this is abstract. Does an abstract class have to implement the interface that it extends? Okay, so let's just keep going. So the point of this is that Hermite is an interpolator. The reason I split out this idea of an interpolator is that Hermite is not the only way to do it. So Hermite finally is a real class, and it is an interpolator, right? Which means that it takes in a point A and a point B, but it also implements get position from arc length, right? float arc length. Maybe we should call this Hermite curve. It's probably more accurate. Hermite curve, right? Okay. I'm getting confused. Maybe interpolator should be like something that Hermite uses. No. Hermite is definitely a interpolator, because the whole point of Hermite is that it needs 2 points. And it's one way of taking 2 points and getting a path out of it. Right? So anyway, it implements this, and then implements all those other functions, like, you know, and we've got that code already, obviously. From here, Hermite, I don't know if you actually use this, but Hermite, I mean, we've got all these functions already. Position from arc length, rotation from t, blah 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 blah. Calculate total arc length, you know, etc. etc. So yeah. Okay, so I'm a little bit confused about what's it called? I'm confused about this. Does this path actually have to implement all these methods, which would blow? I mean, does this interpolator have to implement all the path methods? Well, the point about this is that, you know, a path, you could just get a path from 2 points if you wanted to, right? All you'd need to do is have an interpolator, and then it would give you a path from it. Right? That's funny. I don't know how to do this. Maybe interpolator. Yeah, interpolator definitely implements a path. Maybe this should be interpolation. This is an interpolation. Okay, what's next? Point. Okay, so what is a point? Well, so far point. Okay, so this arrow means uses. So this means that interpolator uses points in some way. So is-a means derive from, and then this a left arrow means has member variables of type one or many. Yeah? And clearly, an interpolator or interpolation uses points. In fact, it uses 2 points. Right? Right. So any kind of interpolator, you just give it 2 points, and it can give you a path out of it. Right. So what's a point? Well, the point is a class. Actually, no. Yeah. Actually, I think it should be abstract. But I'll talk about that now. Okay. So a point is a class, and it has a vector 3 position and a quarter neon rotation. Blah blah blah. Right. And the reason I define that specifically is because, well, I mean, we don't have to use the rotation. We could just use a position. Right? It could just be a bunch of straight lines. You know? Oops, sorry, this should be point. Okay. Okay, anyway. So that explains this little diagram here. An interpolator is a path, and it uses points. And Hermite is a interpolator. And we could use other ones, but anything that derives like Hermite does from interpolator would have to take 2 points and produce all the necessary path functions for those 2 points. Right? Hermite is just one technique. Okay. Now this is the part that is kind of really getting. Unfortunately, this is when it gets really confusing. Okay, so what is track points? Well, track points. What track points is doing is that track points is a path, right? So the whole point of track points is that we've got this list of points, and they're all in order, and they all make up different, and they all they make up segments, right? Each consecutive point, you know, each pair of consecutive points, or each pair of adjacent points, makes up a segment of the path, and together they all form the same path, right? So track points implements path, right? Track points is just it defines a single path, right? So it has a total arc length, even though it's made up of many points. That whole path made up has a single length, and you can get the position at any point along that path. Right? The fact that it implements that using a whole bunch of smaller paths is incidental. Like fundamentally, it is a path, right? Defines all those functions, right? Then the way it does it is it does it using both point, has a member variable of type point. In fact, one or many points, and it uses an interpolator to get the subpaths, to get the paths of each segment, right? So yeah, I mean, I think that this is a good way of looking at what we've done. For example, okay, so why do it like this? It's like, well, sure, I mean, we've only got one implementation of path so far, but if we split it out like this, there's tons of ways in which we could implement these methods, right? So if we now you got your TrackMesher, right? So now we take TrackMesher, and all TrackMesher needs is a path, right? And then a list of things to mesh. How do you actually do that? I actually can't remember now. How do you figure out which slab you're in? You just go through all the slabs, source meshes, style, source meshes. Okay, source meshes. Okay, source mesh style, track points range. It's confusing. Actually, not each track point. How do you actually get the style at a certain point? Anyway, the point is that the TrackMesher, I mean, I'll draw it up, but the TrackMesher takes in a path. It doesn't take in track points. That's just how we implement it. Now imagine if we split it out like this, then we could have a game object that's track points like it is now, and then have have all the points come off as sub game objects like I've done. But we could also have another object that's like a quadratic, right? And it also is a path, right? But it does it using a quadratic function in 3D, right? I mean, and then we could just point that path to your TrackMesher, and it would take exactly the same track and then bend it using an equation instead of bending it using the way that we've come up with now. You see, so then, then I mean, maybe I should define a function called a mesher that takes in a path and then takes in a list of slabs, or whatever. And a slab is got a mesh attached to it or something. I don't know. Or it takes a list of meshes, right? Yeah. So you have a mesher. It takes in a list of meshes and it takes in a path, just a path, anything that's implemented path, any instance of path, and Bob's your uncle, right? And then TrackMesher will be TrackMesher will be an implementation of mesher that Anyway, I mean, it's got on my mind, there's so much stuff to think about. It's killing me. Should I stop it now before I go nuts? Yeah, so okay, fuck it. I'm gonna stop it now, upload it, and keep thinking and draw this out now with the track. Try and see if I can get the TrackMesher into this. Where does the TrackMesher fit into this, right? Yeah, so there's going to be a mesher object, some object that just produces a mesh, right? And the mesher object takes in a list of meshes and it takes in a path, right? That's it. List of meshes. Is C# by reference? I mean, can you have a list of meshes and there's actually only 3 objects in there, even though there's like 20 instances in the mesh? Anyway, I'll think about it.